Hi, everyone. I hope that you're doing well. I'm certainly missing all of you. Today, we are continuing with graphing exponential equations. And I wanted to show you another example of some equations that you may see in which the exponent appears as an expression rather than a single term. So here we have y equals 2 to the power of x plus 2. And while we can certainly use the steps that we learned on Tuesday in the set of videos that I did on graphing exponential equations part 1, but we can also look at the properties of exponents that we've learned so far this year to help us. Keeping in mind that if we have 2 times the power of x plus 2, we have a base of 2, and we have two terms. We have x, and we have positive 2. So if I just separate them as 2 to the x times 2 to positive 2 power, I can go ahead and evaluate that and break that down a little bit. I know 2 to the power of 2, or 2 squared, is 4. So there's my 4. And now I have 2 to the positive x exponent. So this tells me that my y-intercept is 4 and that my common ratio is a multiplier of 2. So I can make my table of values. I can plot my y-intercept and I can say, okay, well, if x is 0, y is 4. 4 times 2 is going to give me 8. I can keep going and reverse that in the other direction. You can always use Desmos. If we look at this one, where we have 3 to the negative x power, okay, that means I have negative 1 times x. Well, if I'm multiplying, right, to get my exponent, that means I have power of a product rule. So I'm distributing that x to the negative 1 to get negative x power. Well, 3 to the negative 1 power, remember, I cannot leave a negative exponent. To make it positive, I need to take the inverse, which is 1/3 to the power of x. This tells me that a is 1, my y-intercept is 1, and my common ratio is 1/3. You can make a table of values, or you can simply plot your y-intercept at y equals 1, and you can multiply 1 times the common ratio, which is 1/3, and keep extending it to the right and to the left. If we're looking at using the properties of exponents to sketch the graph of y equals 2 times x minus 3, and I have an expression there, again, you can make your table of values and substitute or recall the properties of exponents. If I have two terms and the base is 2, I'm going to go ahead and separate them. So I have 2 to the x, but I also have 2 to the negative 3rd power. We cannot leave that exponent negative, so we have to take the inverse of that. So rather than 2 to the negative 3rd power, I am going to have 1 over 2 to the positive 3rd exponent, or 2 cubed. 2 cubed, or 2 times 2 times 2, is 8. So I have 2 to the x times 1/8. This tells me that 1/8 is my y-intercept, and my common ratio is 2. So I'm multiplying every value by 2. So I can make my table of values and I can plot my ordered pairs.